maximize the value of high quality data sets and recognize the data providers to provide a robust, cost effective and sustainable platform that enables appropriate exploration of the data. And by appropriate exploration, we mean encouraging people to be able to make sensible use of the data and discouraging users from inadvertent misinterpretation, and certainly discourage the misuse of data, so that we give focus proper attention on the subject of those studies and the data providers who've been responsible. The team overall includes a group of about 60 people, not all devoted to Clinepdb, but also devoted to some of the underlying infrastructure. That includes IT staff, of course, systems and database administrators, infrastructure and user interface developers, data type developers who are responsible for translating the information into views and visualizations that will be useful. Also, of course, people who are responsible for structuring and loading the data, data loaders and data processors, and a strong ontology team who is responsible for structuring the data that facilitates useful analyses that can be done in similar ways in similar studies. And perhaps most importantly, an extensive outreach activity that involves working with data providers, including some of the people on this call, and also working with users of these resources, which includes all of the people on this call, doing things like running workshops, doing QA work, working with people individually. So I do want to highlight that at the outset that you should all feel free to contact us individually for dedicated meetings at any time that's useful to you. At the top of the page on all of the Clinepdb web pages is a contact us link, which is your one-stop shop for information, for asking how you do something you haven't been able to figure out, asking features that might be useful, setting up a meeting for discussing new data sets, or setting up a private meeting with your laboratory group, wherever you may be located in South Asia, in South America, in Africa, in Europe, in the US, in the Far East, in Oceania, wherever. We run many meetings for individual groups or individual teams with anywhere from 2 to 50 people, and would be happy to schedule those at your convenience. By the very nature of this project, it's a global project, which means that there is no time which is convenient for everyone. This meeting, motivated by, but not part of the ASTMH meeting that takes place next week, is organized in a time frame that is during working hours for those of us who work in the US. But we're also happy to set up meetings during working hours for people in Bangladesh or Tanzania or wherever. So with that, let me introduce Danica Helb, who is a molecular epidemiologist by training and a project and has been responsible for dealing with many data sets over the past couple of years, who will take you through some introduction to Clinepdb. Danica?
Thanks, David. Let me just take a moment to get set up here. And does my screen look okay for everyone? Great. Okay. Thanks for the introduction, David. So I first want to point out that we published an article recently that really provides a strong background into the project. And so I just wanted to point this out to you all. This is a great starting point for getting information about what we do at Clinepdb. And again, we are made up of a very large team. And so this is from our last retreat, and the team has really grown since this picture was taken. And I want to also acknowledge our funding sources, especially the Bill and Melinda Gates Foundation, and all of the data providers that we've been working with over these past few years. So over at Clinepdb, we are committed to making epidemiologic data accessible to the global research community. while protecting the rights of study participants and also the data providers. Before viewing the website for the first time, users are required to agree to the data access and use policy. This policy outlines expectations regarding data use, the protection of participant privacy, and acknowledgement of the data providers and Clinepdb. All data sets allow complete access to aggregate data and visualization tools, but some studies require that users be approved to view and download disaggregate data. The purpose of Clinepdb is to make data fair. Fair data is findable, accessible, interoperable, and reusable. So when data sets are loaded into Clinepdb, they are given a stable, unique identifier, making them findable. We allow users to access data in various ways with a search wizard that allows complex searches to be performed, and analysis apps to allow for visualization of the data online. The Clinepdb user interface enables a point-and-click interrogation of diverse data types. Variables are displayed as interactive tables and graphs, and users can contextualize and identify subsets of data and immediately explore potential associations. As data are selected, the data available for other variables and any downstream steps are identified, so the user can visualize the impact of their selections on other variables. And of course, data can be downloaded in common machine readable formats for robust downstream analyses. We make data interoperable by mapping variables to terms which are harmonized across data sets. Heterogeneous variables are standardized using OBO Foundry ontologies. This creates a unified semantic framework that applies to all integrated data sets, even those with different disease foci. This work is what distinguishes Clinepdb from repositories and study-specific websites, and allows researchers to quickly determine if specific data are available within one or multiple data sets and worth further analysis. We make sure data is reusable by providing study pages that explain the context and methods. The study page provides a description of that particular study goals and objectives, the methodologies, investigators, and links to associated publications. There are also links to data collection forms and data dictionaries, which detail variable definitions, allowed values, and skip patterns. For datasets with access restrictions, there is a table that lists the individuals who have been granted access to the data and a brief purpose of their intended use. Clinepdb can accommodate a variety of study designs, including observational studies and randomized controlled trials. The data you will find on our site is of diverse types. We currently have 27 datasets available on Clinepdb. These datasets focus on infectious diseases such as malaria, schistosomiasis, and enteric and respiratory diseases, as well as on maternal, newborn, and child health. And we're adding new data sets to the website every few months. The Clinepdb database currently includes over 1 million participants with more than 5.5 million days of observation about their associated demographics and disease episode data and more. Site users can view aggregate data for all studies on our site, but at the provider's discretion, some studies require access restrictions to download the data for further analysis. Clinepdb has a tiered system for controlling data access. Currently, we allow full open access to 17 data sets, which are the ones in the bold and underlined here. For the remaining 10 data sets, the Clinepdb team works closely with the original study team to verify access requests within a week. So I'm now going to demonstrate how to use Clinepdb to quickly approximate data in the one of the publications that just came out last month. So this study is using data from the PRISM-2 cohort, and the analysis investigated malaria infection following indoor residual spraying of insecticide in Tororo, Uganda. And so here in figure 4b, we can see monthly trends of microscopic parasitemia that are stratified by age group. So what we can see in this figure is that overall the prevalence in this population is low. And over the course of the study, it drops even further. We can also see that the highest prevalence is in children 5 to 15 years of age, which is shown in red. So I'm going to just navigate over to the Clinepdb website for a quick live demonstration of how I can create this figure on our website. So this is the homepage here, and I can quickly navigate to a study by just typing in right here, PRISM-2. And I'm going to start a search. Okay, so we have organized the data into these different nodes across the top in our search wizard. And so in this study, I'm interested in limiting my observations to those that were done when a blood sample was collected. And so I'm going to type in observation type here. And here we can see that there are 4 different types of observations that were performed. And I know from reading the dataset page for this study that at the entomology visits, blood samples were not collected. So if I want to limit my observations of interest to those where a blood sample was collected, all I need to do is click on enrollment, routine, and non-routine. And so this will filter out any data that was associated with the entomology visits. And up at the top, what we can see here is that of the 36,565 total observations in this study, 14,702 were non-entomology visits. And so this is the set of visits that I'm now working with. So something else I want to point out is that these selections have an impact on all of the other data variables. And so I can quickly see how these selections impact the variable distribution, the value distribution for other variables. So let me give you an example of that. So I'm interested in who slept in their dwelling last night. So what I can see here is that of all of the observations in the study, 3% of the visits occurred when a participant did not sleep in their own dwelling the night before. However, when I'm looking at my selected observations, so the 14,702 observations that were not associated with entomology data collection, I can see that of these, 7% of the participants did not sleep in the dwelling the night before. And something else I want to point out over here is distribution of these visits. And so the gray bars represent all of the visits in the study, while the red bars represent the visits that are associated with my selections. So you can quickly see the distribution and how the values change for all of the variables as you make selections. So now I'm going to move over to view my results. We'll give this a minute to load. And what I see now are a data table that represents the variables that are relevant to my selections. And so one thing I want to point out is that on the column headers, you can see this little histogram icon. If I click that, I can see the distribution of that variable. So I clicked here on observation type, and within my selected observations, what I can see is that the vast majority of the visits in my selection are routine visits. Sorry, I'm having trouble navigating with the Zoom link open. Okay, so now
you didn't notice the time, so I'm going to move on shortly.
finishing up. Thanks, Sam. So I want to now provide that visualization for you all. So I'm going to click on Data Summaries, and again, give it just a minute to load. Okay. So now what I want to do is for my y-axis, I'm going to select Plasmodium asexual stages by microscopy. And I want to stratify my line by the age categories. And then I'm stratifying my plot by the observations I selected. So again, these are the visits that are not entomologic visits. And so now that I've selected my plot parameters, I'm going to click over to plot grid. And yeah. So now, again, we can see the distribution of microscopic parasitemia over time in the study period. And you can see that the age group that had the highest prevalence is the 5 to 15-year-old age group in green, which is what we saw in that publication. So that is it for me. So I'm going to stop sharing and thank you all.